The question is, which row shows the properties of transition element? The first option is talking about the catalyst. Second, talking about the color of oxides, electrical conductivity. As we know, the transition metals, they are used as a catalyst. So A and B are correct. They are used as catalyst. Then color of oxide. Color of oxide give green or red color. Yeah, it can give these colors. But the last one, which is electrical conductivity, it can indicate the correct answer. A is all of transition metals, they are good electrical conductivity. So the first one is good electrical conductivity and used catalyst, and the oxides also gives a color of oxides like iron oxide and copper oxide. So the correct answer is A. The question is, fluorine is an element, of course, at the top of group number 7 of periodic table. Which statement describes fluorine? It is an inert? No, of course. It is very, very active nonmetal. It's monoatomic? No, it's diatomic molecule, not monoatomic molecule, as it gives F2, it must be F2. It is non-metallic? Yeah, of course, it is non-metallic. It is solid at room temperature? No, it's a gas. As we know, fluorine is the most non-metallic element, electronegative element in periodic table, so it is non-metallic element. The question is, when aluminium is placed in dilute hydrochloric acid, there is no reaction. When zinc is placed in dilute hydrochloric acid, bubbles of gas immediately given off. Okay, the aluminium, of course, it doesn't react as it covered with a layer of aluminium oxide. Look for the options, what we have here. The first option is aluminium is coated with a layer of aluminium oxide. Yeah, this is the correct answer. Of course, aluminium is very reactive, so it got oxidized direct with oxygen and give me a layer or coated by a layer of aluminium oxide. Prevent this reaction with hydrochloric acid. But zinc, it can react with hydrochloric acid and produce hydrogen gas as bubbles. The other options, aluminium is more reactive than hydrogen. Yeah, aluminium is more reactive than hydrogen, but this is not the reason. Okay, aluminium is less reactive than zinc. No, this is the reason. Zinc is less reactive than hydrogen. Okay, so the correct answer for preventing the reaction of aluminium with hydrochloric acid or dilute hydrochloric acid is this layer of aluminium oxide, as aluminium is very reactive, so it got oxidized direct with oxygen to give us aluminium Al2O3. Al2O3. This aluminium layer or this aluminium oxide layer prevent the reaction of aluminium with hydrochloric acid. The question is, which statement about the use of sacrificial protection to prevent iron from rusting are correct? Okay, the first one, a more reactive metal than iron is used as a sacrificial protector because, okay, up till now is correct, because it undergoes a reduction before iron. Reduction? No, of course no. Oxidation before iron, as they are metals, they got oxidized before iron. Okay, so the first one is not correct. Zinc is used as a sacrificial protector because it gains electrons. Gains electrons? No, zinc should lose electrons. Zinc should lose electrons to convert from Zn to Zn positive 2. So the here in zinc, no, it couldn't, because Zn converted from Zn to be Zn positive 2 plus 2 electrons. So this option is not correct. Copper is not used as a sacrificial protector because it's less reactive than iron. Yeah, it is correct. This one is correct. Magnesium, of course, copper is less reactive than iron, so we cannot use it as a protective or a protector for iron. Magnesium is used as a sacrificial protector, of course, because it loses electrons. Yeah, more readily than iron. Yeah, of course. So 3 and 4 are, both of them are correct. So which option here? 3 and 4, D. So the option D is the correct answer, which is telling us copper is not used as sacrificial protector because it's less reactive according to the series of reactivity than iron. Okay, less reactive, so we cannot use it. Iron is more reactive than Cu. Okay, so we cannot use copper to protect iron. Second one, magnesium is used as a sacrificial protector, of course, because it loses electrons more readily than iron, so it got oxidized readily or faster than iron, so we can use it as a sacrifice, or we can sacrifice by magnesium instead of iron to protect iron from the rusting and corrosion.